Hi, welcome to the July 27 meeting of the CNCF IoT Edge Working Group. On today's agenda, we're going to start with a brief 10-minute-ish discussion of a white paper on Edge that this group is working on. And then that will be followed up with a presentation on Project Flutter, which has Edge device management combined with Kubernetes. So with that said, let's jump right into the white paper discussion. If anybody who is organizing that wants me to make them a co-host because he wanted to share anything, go for it. Otherwise, the alternative is if one of you could post a link to that document in the chat so that people new to this topic can take a look. Thanks.
Thank you, Stephen. This is Brandon. I've just gone and added a link to the white paper outline draft in the chat. Quick reminder, we've been working on this now for several weeks, and this group's had a couple discussions already. Unfortunately, both myself and my colleague Amar were unable to make the meeting 2 weeks ago where the paper was discussed at length. But we've looked through the comments and the minutes and just wanted to respond to a couple things and then also just get this group's quick feedback. I realize we do only have 10 minutes and there's another topic, so I don't want to take up that time. But we want to keep making progress on this outline so we can look to finalize it and then start drafting. So if I could do a summary of some of the feedback that I saw. We want to make sure that we're not duplicative of existing efforts. And we've looked through some of the other materials. There was a white paper from our friends at Huawei and in China. That was interesting. It was pretty broad in terms of personas. I think the CNCF angle would be a little bit more developer specific and also a little more technology agnostic. There was a suggestion to potentially consider a NIST definition, and an example was provided. And then there was an idea around if near edge could or should be the focus here before we expand out. Amar, did you have any other thoughts to share?
No, I think you covered it, and I reviewed the Huawei paper, and it does have some points for developers, but it's sort of sprinkled and it's not focused on that. So I don't think we'll be duplicating that particular aspect, and also I think it's more opinionated in terms of prescribing technologies. It comes from an edge gallery point of view, which has things like sharded databases and all in the platform itself. Well, I think a Kubernetes perspective would probably be more sort of neutral, is what I'm thinking. So I also feel comfortable that it's not duplicative.
Okay. Other thoughts from the group? Would love to hear your inputs, especially we weren't there on the last meeting, and would like to know how to go forward from here.
Just to comment along this line. So one of the goals of this white paper also is to get a broader audience of feedback from hopefully KubeCon North America. And so we submitted a proposal to kind of discuss our status there at KubeCon North America. And I think I can I'll find the abstract and share it here of kind of what, if it's accepted, people would read the session looking like. That's also a goal to work towards, of being at a reasonable state by then. I think it's mid-October.
Not to clutter the waters, but I just got an email from the Eclipse Foundation in the last couple of days with a link to a white paper they published. I dropped that in the chat. I don't know if that link is specific to me, so let me know if somebody tries to open it, whether that actually works for you or not. But it looks like a very general paper from my perspective, and there's still room for others. I think there has always historically been overlaps in these with different focuses. The Eclipse Foundation, for people who didn't know, sponsors a number of projects that are useful at Edge, but so does the CNCF. So I think in some cases, these white papers coming out of the orgs kind of spotlight their own projects. And I don't know that's a goal for the one we're working on here. We're kind of so broad in scope that I'm willing to open it up for anything, including covering projects coming out of open source areas that aren't in the CNCF, because I think the whole point is to serve potential users, not to serve the foundation itself. So that's my attitude.
Great, thanks for sharing that. Has anyone else volunteered to be an author of the paper? Right now, we're starting with two, Amar and Robbie from Verizon. Has anyone expressed an interest on taking a section or two?
I may entertain it. I don't want to take on the scope of being sort of the czar of the whole document, but for things that maybe I have specialized interest and knowledge in, if doing a piece of it constitutes being an author, I guess let's clarify that too, because you know, I wouldn't expect that if you write 2 sentences that you necessarily get listed as an author, but we could do it that way if we don't mind a huge list of authors. And I'm just not sure of the scope of my participation, but I do intend to participate at some level.
Okay, great. Thanks, Stephen. Yeah, I think we can work that out when we have a better idea of how many and how long. So I see we're almost out of time here. Any other thoughts from the group about how we proceed? Should we, I put this out on the mailing list as well as the Slack channel. Got some feedback, but not a ton. Is there anything else we need to do to start finalizing this outline and then start drafting?
Well, I think this came up for Chad in the last meeting that you missed, that we wanted to try to do this asynchronously because, you know, pretty much everybody is in a situation where you can't make every meeting. And by allowing contributions in the form of direct edit contributions or comments, people can kind of work offline. And the idea was that we would allocate 10 minutes at every one of these recurring meetings to go back and visit it and go over the comments. Now, this we kind of did broadly, but I think to get to a final document, we kind of probably need to open that document, go through comments and address them and close them. And I think that I've seen that work in the past on these white papers. So that's just a proposal, but you know, I'm open to others, but I think that would work.
Maybe we can aim to have the outline fully finalized by the next meeting. And I think a good thing we could do is go through and assign people sections. So that would be kind of a good time to decide whether any of the sections would be good for you before the meeting. And then we just go and put someone's name by it. And obviously that can change, people can swap, but then we'll have some working material for the meeting after that.
Okay, Kate, do you want to be the person in charge of putting people's names on? My opinion is to get it done fast. It's better for it not to be 100% democratized to where we get consensus on micro decisions. And that sounds like a great idea. And if you want to do it, fine. Otherwise, how about if we appoint somebody? And it's not to say that, you know, the rule is final. If you get assigned something you don't really want, just say so. But let's try to move this quickly by making some of these micro decisions just in the hands of one person.
Okay, I get what you're saying. So instead of just everyone volunteering what they want to do, just put a name by each section, and then people are in charge of switching what name they're in or section they're in.
Exactly. You know, somebody could take a first pass and just take a guess. And if you don't like what you got assigned to, just change it yourself. How does that sound?
I'm open to that. What do other people think of that? We can also do a preliminary time period where it's like, okay, for this week, comment next to the section you want to take. If you don't comment, then we'll just assign you. We can kind of do
Okay,
a
that
hybrid.
sounds great. Any objections to that? Okay, I'll take silence as no objection. So let's go with that plan. So go in that white paper, go assign yourself sections. If there's 2 on a section, I think that's okay too, if 2 people want it. But we'll go with that. And then if there's gaps later, I don't know, Kate, are you going to take on assigning names or should that be somebody else?
I'm fine to do that as long as we know the names. It seems like right now we have a couple people who are interested. So I'll put in the Slack kind of this, what we just discussed, saying, hey, over the
Okay.
next week, go through the white paper, see what you're interested in, comment that you're interested. Otherwise, comment in this thread that you're interested in participating in some way, and I'll give you a section, something along those lines.
Okay, sounds good. So in the interest of time, we already shaved about 3 minutes off his allotment, but I think Eloy is here to speak on Flutter. I believe I made you a co-host, so let me know if that didn't appear to have happened. And how about either Dion, you can introduce him or he can introduce himself, and I'll turn over the mic to you.
Okay. I'll let Eloy do all the work, right?
Yeah, let me share my screen. Oh, let me see if I can share.
We're getting something, but it looks like gray diagonal hash lines, not something visible.
I cannot share or.
Okay, we can see it now,
Getting it.
but it looks like it's zoomed in so that it's cut off on the left.
Yeah, let me see. I mean, I don't use Zoom for.
There's 2 options in Zoom of share a whole screen, which is like your whole monitor, or one monitor if you have dual monitors. And the other is to point out a particular application, and then it should just grab the screen for that app.
No, I don't have. I have whiteboard and advanced. I have like portion of the screen, but I cannot change the portion.
Okay.
That's
Now it
weird.
just says you've started screen sharing, but we couldn't
Let
see
me-
anything.
Let me see. Maybe this is because of the Fedora Wayland.
If this is actually a deck that someone else could open and advance for you, maybe we could try that as a fallback too.
Yes, maybe. I don't know if Moti, Piotr, or Jordi can try to share, but I cannot share the demo. That's
Okay, let me make Jordi a co-host too. And you said Piotr too?
Piotr or Jordi or Moti.
Okay,
That are my
Jordi's a
colleagues.
co-host and I'm working on.
Can you share, Jordi?
And Jordi, I think we can't hear you. You might be muted.
Hello, can you hear me? Perfect, thank you. Some issues with microphone. Eloy, have you tried sharing with your laptop screen instead of the external monitor?
Yeah, but I don't have like. I don't have like that option.
No, I mean just move the window to your laptop screen and then just share the laptop screen. Yeah, now we can see it.
Now you can see it?
Now we can see it.
Okay.
I mean, it's actually very small, so you might want to resize it.
Okay, so let me. Oh God. 1 second, Sam. Can you... Let me do it small.
Almost there. Now we're seeing your Slack. Now disappear.
now-
Nothing you can share. It doesn't work. Yeah,
Now
I think
you
you
can
cannot
see.
share it. No. I think it's Wayland. Okay. Does anybody else have the slides at hand, or I need to pull them? Piotr? Moti? Do you
Let me
have
share
them
it.
around there? Yeah.
And by the way, we got some glimpses of your Slack. If there was a privacy issue there, let me know and I'll remove it before the recording's published.
Can you see now the slides?
No.
Just the gray box.
Yep.
Should be something with Wayland.
Mm-hmm.
If not, Piotr, but you are going to lose the. You're going to lose the demo. Piotr, are you saying or? Okay, now I can see all white, Piotr.
Steve, can you open the link? Because your system probably works, and we don't usually use Zoom.
Can you just share Zoom?
Yeah.
Steve, you're muted.
Okay, I don't see a link in chat. Where did you put it?
Oh, share with you.
Just a minute. It's saying I need to request access, so I'll do
Yes,
that.
you request it and I will share with you.
Let
Okay.
me try it.
I'm sorry for the issues. So,
Yeah, that's okay. It happens.
I mean, the bad thing is like you are going to lose the demo. But if you are okay, I will record the demo after the call and I will send to all of you so you can append
Yeah.
in the.
Or we can do it some next meeting. So it's not
Maybe we can just
One-
try to do this
one-time offer. Yeah.
Okay. So let
without
me.
the slide deck. Might be better than none, but let me see. I requested access to that document.
Yeah. You have already. I mean, you are
Oh.
saying that.
So I shared it. So it's
Okay.
currently.
Oh, okay, got it. Okay, we
Okay.
can see it. This looks good.
Okay, so let's go to Flutter. So I'm Eloy from Flutter. I'm with my colleagues Jordi, Moti, and Piotr. A few other more that are not here. We are working on Project Flutter. Project Flutter bonds inside the team special projects inside Red Hat. We aim to work on the in-depth solutions for small footprint devices like Jetson boards, Raspberry Pis, Intel NUC. It has some use cases. So what we are focusing in Flutter, let me see, because I think that. Okay, so what we are focused, go to the slide before.
Mhm.
So what is the main focus for us is three things. That is like the device lifecycle. In this case, is the device onboarding, device configuration, and the OS lifecycle, like updated and rollback. For onboarding, we have our process, but we also integrate with FIDO, the FIDO device onboarding process. That is something that Fedora IoT is working on, and we already integrated with that. About device configuration, per each devices, we have like the configuration to get in workloads and stuff. And we also will integrate some kind of Ansible workloads in there. So as soon as a new device joining the fleet management solution, you can run any Ansible playbook in there. That is not in there yet, but it's going to be in the next release. The work is almost done. And also about the updates and rollbacks on the operating system, we are basing our system RPMOS 3. So we know how to do updates in the life cycle, do incremental updates. If something fails, going back. I will explain this more in further in the next slides. We also care about the application life cycle, like how you define the application, how you run the application. So we use the same spec as the pod in Kubernetes. How you run, that is like the application runtime. That is what we use is the Podman Plague Cube. So we rely on Podman Plague Cube. More than running the applications, we also have like the data collection, like you can sync with any S3 like tooling, like S3, Topple, VM, Minio. So we have a way to push data and retrieve data from S3 inside the workloads. And we also taking care about the observability and the log collection for the workloads. About what is the cases that we aim for are the edge environments that we say that we are good at, or at least we want to be good. It's about the disconnected environments, like a device that can be disconnected for long periods of time. That can be like in a train, that's something that lost the connectivity in the middle. So something that is not, the network is not reliable. We care about the multi-arts. So we build for x64 REM. In REM, we only provide support for 64, even that we can provide support for REM 32. But at the moment, we only focus on 64 bits. As I say, the flaky networks that we can lose the connectivity in any moment. Also, because the devices that we want to use is more close to the IoT that the 5G Edge is more like a minimal footprint. So we just care about consuming low footprint in memory and CPU. Now we have a Google Summer Code project to work in the consumption, like power consumption, in the projects of the device, because we know that is a hard part for these devices, because maybe they are running on batteries or in solar panels. Security is something that we care about, because security is something that is something that is never-ending job, but per each release we are trying to work in the security stuff. So it's trying to getting better and better in security and implement more features. Like now we have MTLS connections for all rootless Podman, but we want to implement USB guard, MacSec, and all this kind of security tooling that we have, and it's important on the edge. If you can go to the next slide. So the use case that we focus on are like one is the retail companies, like thinking a company that has multiple store across different zones, like in USA in this case. This retail company can have a point of sale system, a video surveillance system, some sensors about how much electricity consumes or music in the store or something like that. So a lot of devices that can be part of that. And what we want is to manage all these devices inside the Kubernetes cluster using the CRDs, and you can define like a edge device, an edge workload, and running these workloads like our container inside of the all retail stores that you want. So the networking there can be like any store can lose the connectivity in any moment, and it's not reliable, but you know more or less that across all the stores, you can get like the same configuration and the same application runtime that you have in there. Next slide. Another use case that we have is about the industry, like a manufacturing lines that maybe has a small Kubernetes cluster in there with 1, 2, 3, 4, 9 nodes, and need to do some kind of containerization application that is part of the robotics arms or sensors that checking the things that need to have observability about, okay, if this robotic arm performs as expected or resets it down when it should, you know, like all these workloads that can running in the manufacturing line. So maybe this Kubernetes cluster can be inside of the factory. There is something that pushing this, pushing change to that Kubernetes cluster with the Edge administrator. So this is more or less the use case that we can think of. Also, like you can think about trains, drones, or something that is more or less in this case, but more or less this is the important ones that we think of. Next slide. About the Flutter internals. So mainly we need a Kubernetes cluster. And this Kubernetes cluster, we have two main things that are needed. That is the Flutter operator and the Flutter Edge API. We rely on etcd, on CRDs. So we have 4 CRDs, that is Edge device, Edge device sets, that is a group of the device, Edge workload, and Edge single request, that is some kind of approval process that we provide. Flutter operator just taking care about the updated, do the reconciliation needed in the CRDs. And the Edge API is how the devices communicate with the Kubernetes cluster. This API is something that we build custom. It's a HTTP API. It's secured by MTLS certificates. At the moment is normal certificates, but we want to use TPM in the next release. So the communication between the agent to the Edge API will be secured by hardware. On the down, you can see the Edge device. In this case, we need to install the device worker, the Flutter device worker. That worker is the only thing that is doing is pulling the information from the Flutter Edge API on a herbit seconds. That is like we have a herbit that can be configured by the Edge administrator. Can be 60 seconds to 5 minutes. This device worker just interacts with Postman and systemd because we want to have the minimal footprint possible. We rely a lot in the systemd, like running the workloads with using systemd that is generated by Podman. We interact with Podman to get in the information about the containers, but we only push we are using Podman PlayQ. That is like we can interact. We can send the pod spec directly to Podman. Is getting in there. Systemd is taking care that the workloads are running, that if died to recover from the dying and all the stuff. So more or less this is how Flutter works internally. So let's go now over the CRDs to the next. The first thing that you can see in there is like the first CRD that you can have when you install. You have a Raspberry Pi, you install Flutter Device Agent RPM. And as soon as you install that, you register into your Flutter cluster. And you will have this Edge device single request. That is the approval process that we have. You will get the name. That ID can be from the machine ID from the installation, or can be the FIDO ID, UID. And in there, the system administrator need to approve the device if it's trusted or not. Used to run the Ansible playbooks or to run any kind of the workloads that you want to run. So Edge administrator need to say approve true. It will have like the information that in there, like you can see in there is good, but you will have like the hardware specification, the CPU information, the system vendor. After that, you can define the target namespace. So for example, if a user want to have, okay, this device is from the New York store, so can have like a namespace for these devices, and can have like custom config maps that can be used by workloads and all this stuff. in that namespace. So the separation is total in terms of the how they manage that. And they can also apply labels on that side. So next slide, please. As soon as the device is approval, we know that. And what we do is like we created the edge device. That edge device will have like labels that are managed by Flutter itself. So you can see in there like device, CPU, device CPU model, host name, and all the stuff. This is created by Flutter used to the identification. Because we run the workloads based on labels, we have like the device selector, all this kind of tooling like any service. You can define any labels and put the workloads in there. That spec of the edge device is high because you can define a lot of things in there. In this case, you can see in there like the heartbeat, like every 2 minutes, you will get the latest configuration from the Edge API. If something changes, it will apply all these changes, like, okay, a new workload is in place, or something new that is like a new Ansible script need to run. We also have like the, as I say, the RPM of tree information. So in this case, we have like the OS information and we say, okay, we are going to upgrade if a new commit is in place. So it's the main thing that we can say, okay, update it as soon as the security update happens on a RPM tree repo or something. And the request time, that is when the device is created. Next slide, please. For when you have a lot of devices, maybe the customer want to, or the user want to have some kind of grouping of the configuration. As I say, we implement metrics, log collection. So one of the things that we have, that we introduce, is the edge device sets. That is a way to put the configuration for all the devices. So in there, you can see like it's the same spec as the edge device. And you can see in there, like in this case, we use the metrics and we say, okay, this sample set is going to store the metrics for 200 megabytes maximum for 24 hours. And we have a log collection that has this syslog with this buffer size. To apply this set device on this edge device set into the device, you need to add a label. In this case, you can see in there that we added a label, the Flutter member of, and we set the set that we have. Next slide. And now the device is fully configured. I mean, you can have like the device ready to get in workloads, to get in the observability from the system monitor or wherever. And now we focus more on the workloads. As I say, we schedule the workloads based on labels, like with the device selector as any service. All the workloads are managed by Flutter device agent. Like if something is deleted or any workload is deleted, the device agent is going to delete it, update it, or update it. We have the system integration, as I say, like to keeping the pods running for a period of time. Multiple options here to use a private image registry if needed. You can use config map and secrets in the pod spec too, if you want to. We define the workload as a pod spec, so you can use like the config map, host device, all the stuff. We also have a way to say this workload image is going to be auto-updated in case of the devices. Thinking like some security updated. So you set the device and we check that if the image is updated or not to update. And something that we had in the last release is like rootless podman, just because if any workload gets compromised, don't get access to the whole edge devices. So we try to reduce as much as possible the security threats that we can have in the device, even that we know that there is still a long journey to getting into the more secure way, but this is more or less what we try to do. Next slide. So the main CRD that we use is this one, the edge workload. And here you can see like it's part of Flutter. We have like the name, the sample app, and we have like the bar selector and say, okay, all the devices that has the labels AVP full will get this workload. In this case, we have the type pod. At the moment, we only support pods, but maybe in the future we support more things like in there, like can be deployment service or whatever. So we keep that option a bit open. And we have the pod and the spec. As I say, that spec is the same as pod. So for someone to run edge devices, it's going to be the same as the pod spec. So can copy and paste it and just change a little bit how we manage the workloads, but overall it's pretty much the same. Next slide, please. One of the things that I said that we focus on is the observability part. So we know that the networks are not reliable in the edge. So what we do is like our agent implements some kind of we get some code from Prometheus, like the scrape system and the TSDB. And what we do is like we have like the edge device configuration. Like you can say, okay, this device can store 200 megabytes of metrics for a maximum of 24 hours. I'm thinking like the workload is running, and we scrape the workload metrics that is defined in the edge workload, and we define, okay, this workload has this metric, and we scrape the information into from that. We store that information into the device, and we send it in batches to a remote TSDB like Thanos or AWS time stream using remote write from Prometheus. The reason that we did this is because thinking that you lost the connectivity and maybe this workload start to fail. Like because there is no connectivity. If you don't store this in a buffer, you will lose that metrics, and you will lose like all this stuff. So this is why we put these buffers in there, because we want to store that if something happens. At the same time, in the next release, we are going to work in reducing the control plane bandwidth. So thinking that if you have like a edge device connected by 3G or 4G or whatever, the control plane information is not important at all. So maybe we add in the edge device, like, okay, the control plane can only take 500 kilobits per second of the bandwidth, because there are a workload that has more priority onto the internet connection. So this is why we added all these kind of metrics and buffers. We have the limits because we know that we can kill if we store all this information in there, we know that we can kill the device for a long period of time, but we provide the customers the way. At the same time, this is pushing information from device to the Prometheus, so Prometheus does not need to have the option to have direct access to the workloads itself. This case is Podman. There is no CNI at all. We open the port, so it's hard to get all these workloads metrics without the pushing method. Next slide, please. So the same for logs collection. So we assume that the network is not reliable, and the same way as we do the same way that we did with metrics, we have like the buffer size. You say like, okay, we have the workloads, the container. We read the logs, we save in the buffer, and we send it to the server that we need to send to using the TCP connection in batches and all this stuff. The main reason is that it's like we don't want to lose the information, even that we know that the buffer is full. If the buffer is full, we cannot do anything at all. We need to drop the whole logging. But we know that we are not going to kill the device. But we know that if something lost the connectivity, we make sure that we can push. At the moment, we only implement syslog. But the idea is to implement more protocols here, like Kafka message or Loki or S3 directly. So it's a matter of a user trying to implement it, we already work on the way to have that. Next slide, please. About the life cycle of the devices. So what we do is like we do the RPM-ostree technology. RPM-ostree is, you don't know, is you have a RPM, you install it, and you rebooted them with the new RPMs in there. So you cannot write it into the disk itself. RPM is similar to Git. You have like commits and you have branches if you want. So what we achieve is like you have like the RPM-ostree, and you can define like in the edge device CRD in which commit you want to be. So you can have like any GitOps tooling like, okay, I want to update these devices to this commit ID, or you can say, I want these devices to be out-updated because I don't really care about the things. And we also implement the green boot scripts. Like if something happens, you get updated, you get update when rebooted the server, something is failing. There is like a kind of green boot scripts that is like, okay, Flutter is running, systemd is running, Podman is running, everything is working as we will like, we started the workloads. Something that we want to implement in the next workload is like, okay, what happens if a workload, thinking like a Jetson board, you get a kernel update, and for some reason you lost the GPU driver or something like that. We are going to update, and for us everything is working, but not for the workload. So maybe we are thinking a way to have like the workload making a green boot script for the workload. Like we don't know how yet. Like if we implemented like the same ways as Kubernetes in the pod spec, or using another things like that we don't have clear. We have a document that we are trying to bootstrap this, but overall is the main goal of the life cycle. Next slide, please. And this is the Flutter resource. That is like the documentation, as I say, the data upload, like how to sync with S3, how we do the observability, how we do the CRD definitions. Everything is in the Flutter project. Now is the moment for the demo, but I cannot share my screen, so I cannot demo that. But if you are okay, maybe we can go to the web, and there is a demo, like a RC schema demo. I'm trying to see that demo, and you can ask questions on there if you are okay.
Let me do that on.
I'm sorry. I mean, I tried to. I joined it before, right, for the Zoom. It's working, but I didn't share my screen, so I didn't know that. Sorry.
Give me just a sec to try to. Okay.
So that one. So if you can start, I'm happy to.
Yeah.
Okay, so in there you can see like if Flutter is started. So mainly we see like Flutter is in there, like all the edge devices.
So I stopped the demo, so you can tell me to pause it and
Yeah,
move it on.
Let's go. Yeah. So now we see like there is no single request from there. So you can see like we started a few devices and we created the namespace for New York. Now we set the approve it to all the devices. So mainly there are a few devices in the New York store. And in there you can say like, okay, these devices are approved and the target namespace is going to be New York. So let's go. I know that this So now, can you stop a little?
Yep.
Yeah. Okay, so now in there you can see like there are 3 edge devices. Can be, in this case, are fake. I mean, there is like a VMs when I run in this. So mainly these edge devices is like how you run. A customer will see like the devices itself. The name here is fake too, but can be the UUID or any kind of information that can be part of the metadata of FIDO, that the FIDO device onboarding. So this is something that the customer can say, or the user can say, okay, this is the right way. Now we label some devices. Can go. In this case, we say app camera and the kiosk. And now it's going to deploy the workloads. If you see the workloads, can you stop? You see the workloads as I said before. So we have like, okay, for all the device that has like x64 architecture, that is a label that we added, just deploy this random engine export in there. So this is how you add that. Let's go to them. And this is the same for cameras, and you see like everything's in there. And now if you see the device in there, there is like the status of the devices. In this case, you can see like the devices are deploying, like the devices are deploying like the tooling, and you can see like, okay, there is labels and it's trying to deploy the containers. And this is the workloads that are running into the device. For these workloads, we have metrics that you can use, like there are metrics that you can use in Grafana. So we try to deploy all the stuff in the metrics, and we provide some kind of Grafana dashboards that you can see like, okay, this device has 4 workloads, 3 of them are not running or are created but are aborted, or what happens with that, and also all the tooling that I mentioned, that upload, observability, and all the stuff. And more or less, this is Flutter. My demo today was a bit cooler. I'm sorry. Any questions?
Thanks. That looked great. I know it's tough while you're talking to be keeping up with the chat, but I think a number of questions came in to the chat. Most of them, but not all, got answered by your fellow teammates on the project. Let me just call out the ones that didn't get answered in the chat. I'm just curious as to how the device to control plane connection works. Does the device call in like an agent where it initiates an outbound IP
Yes.
or other connection, or does it go the other direction?
Flutter device agent started the connection to the Flutter Edge API. We have a registration client certificates. We use that. You need to append, and this is part that we do in the FDO, in the service. So we append that configuration into the FDO client. You initialize the thing and started the connection. So it's pulling method.
Okay, and then the frequency at which it calls in, I think I might have seen it configurable in that configuration. Is that right?
Yes, it's
okay.
part of the device. I think that the default is 60 or 120, but can be like for hours or can be for minutes.
How small in terms of resource can this device get? I mean, it's not a Kubernetes cluster node, but it does have to have a container runtime and things like that. In terms of hundreds of megabytes or gigabytes, what's the smallest you'd think this could go?
The device agent, I think that is 70 megs in total. And after that is what Podman used on the Linux itself. The last time that I saw, I think that we were around half a gigabyte, like 500 megs with all the stuff in there.
Okay, so basically, if you can run the Linux OS plus the container runtime and have enough left for your app, you should be good. So, but that sounds about right.
Now memory, Raspberry Pi is getting powerful, like in terms of memory. It's like it's no longer 2 gigabytes. But I mean, we would like to work on the Raspberry Pi Zero too. That is like for kiosk and all the stuff, but we have problems with the Wi-Fi. This is still things to work in there.
In terms of that config, does this work then if the device itself cycles power, comes back up, and can no longer talk to the control plane immediately? It resumes the prior config and executes on the last known spec. Okay.
Yes, this is something that we're working hard on that. That is like reboots and keeping the last information, and we store and reboots. As this is a part of the RPMOS tree too. That is like every time that we update it, the workloads are running. This is one of the things that we.
Does this anticipate being able to support 100% air-gapped environments, meaning you're air-gapped 100% of the time? And I realize you might have to put up your own container image registry and things like that behind the air gap, but is that something that you're prototyping and expecting it to be useful for?
Yes, we plan it like air gap, and we plan also that maybe something moving and registering to edge devices, everything is working, start moving, losing the connectivity for hours and coming back after that. So it's like air gap totally.
And then there was a partial answer, but I'm just curious about the built-in support for S3 based data collection and why it went that direction of S3 versus existing time series database applications. I assume there's structure on what you throw down into S3, and maybe I'm wrong here, but it sounds like you maybe invented your own, or
no. S3 is like a way that to share data between devices and S3 buckets.
Oh, okay. So it's like
there are two different topics
from many locations.
Yes. So there are two different topics, and the TSDB, the internal TSDB, is more like the observability part that we do in the Flutter agent, and we pushing the data to Thanos or
Okay. Yeah. In the presentation, I got confused and thought maybe this was there just for kind of historical data collection or something, and I completely missed the idea that this was a means of sharing information across edge nodes.
No. This is more like getting information from S3, like having a bucket having a folder inside of your workload.
Yeah,
and
so
it's like
shared storage basically across kind of a wide area out at edge. That sounds really cool. Okay, I'll have to think about that, but that is kind of a unique aspect that I haven't heard come up much, but should have a lot of usefulness. And I assume that that's sort of designed to be asynchronous too, so that if you did something like event-driven programming and one device got severed, that it could kind of catch up at a later date as to what was going on other edge devices.
So around the data upload or what?
Yeah.
I'm not sure if, I don't know, because that part is something that I don't work on. So maybe Piotr or
basically we do a sync between the contents of the bucket and what's already in the volume. So we leave it up to the sync process to catch up whenever there is a connectivity. But we aim to run Flutter on a disconnected environments. So we assume that the device can be disconnected at any point in time during some time. It's not specific, but that's why we added the TSDB inside of the agent, and we added the log capturing and all these things, because we believe this is important to keep the observability alive even though the device is disconnected. And then you can, once it's connected, you can push it to the control plane or whatever needs to be pushed.
Okay, thanks. At this point, I better stop monopolizing all the questions. I'll point out for people who miss some that if you open the chat thread, there's a lot of questions plus answers there. And I've made an attempt to go in cut and paste things from the chat and also the audio into the agenda notes doc. So there's Q&A, questions and answers there. But if anybody else has anything, speak up now. We've still got a few more minutes left.
You want to go? I saw your question last.
Regarding the deployment and the pod, how we move that way. Use card. I mean, there is no good way to update it. It's something that we work on, like how to do the upload, like a blue-green development. Something that we need to figure out how we do, and mainly because these disconnected environments, and it's like it's hard to get it right. So at the moment we are trying to get the feedback from the users, and let's move into that. And this is why in the workload you see the pod type. We want to support that. Something that we are not sure yet how we do that, or how is the good way to do that.
What would be your
One
feeling
question
on
from me.
how? Oops, go ahead. Sorry.
Okay. So you mentioned rootless deployment. So how do you run workloads that need elevated access rights for like accessing the local resources or devices or things like that?
So for devices, it's like more like we are fighting now with that. There is like the Linux stuff, and you can share, you can mount the devices and sharing into the pod spec itself. If you need to privilege on that, you can use the seccomp profiles, like or the privilege mode there. So you can say, okay, this pod has access to the cap admin, or all this net admin, or is the way. It's going to be long journey, this one, because we know that it's difficult. When implements like devices, it's always tricky to do like the good way. We are working on that.
Yeah. Also, another thing to consider is that the way I see at least a nice device is that something that is going to be running a specific set of workloads for as long as the device is alive. So when you ship the device and you onboard the device locally first, I guess that you will first set it up properly with all the permissions so you can run those workloads once they are deployed. So in the terms of security for SLinux, there is a way you can actually add the module and you add permissions so you can let the container access the device or the host device that you plan to use. Let's say a webcam or some other mounted devices. So there is a way to do it through the pod spec, and there is also something you can consider doing as part of the SLinux onboarding process for the device.
Thanks.
And this, Mark, is also related with what you say about the deployment, like what happens with the host device that is used, like a device that is in use, like a SAPI interface or the serial interface that is in use by any pod, and you have a new deployment coming in, and it's like it has no access to that device because it's used by others, and the same for ports. Like for example, you cannot have you open the ports. But what happens if you need to have the same port? It's difficult to manage the way. Has too many implications that, even that we love to do that, is difficult. But should be something like shut down one pod and trigger another one, see that everything works. If not, coming back, and it's like, so it's super tricky. Sometimes we need maybe this when users need to say, oh, this is the right way to use that. When we see like IoT solutions, it's more like they are using like a use replacement of the program, so it's hard.
I'm curious as to how you see this fitting in with what I'd call like a GitOps methodology, where people put specs for what they want happening at a device in a Git repository. Would you see this being an alternative to that, or something that could work with that model?
It could work, and it's something that we aim for. like you have like your application in your Git, you have your containers, something get updated. And it's like, yeah, use update all the devices that you have in there. Like thinking about any company that has a lot of stores across USA. I want to update my point of sale system in the night. Just putting in there like the GitOps and do the updates over the post system 1 by 1 or 10 by 10. And it's like you have multiple options to work in there.
Okay, we're 3 minutes after the hour, so we're pretty much at the limit, but last call, if anybody's got any questions. By the way, that was a great presentation. I really appreciate the effort you put into both the project itself as well as the presentation. I think even though we got a little rough start, a lot of information got delivered and I appreciate it. Anyway, last call for questions. Okay, I'll take silence as none. Thank you very much for
Thanks, Ellie.
speaking on this topic. I think that it's interestingly enough and aligned enough with this group that maybe we'll ask for a refresh in 6 months or so, because
for sure.
this is just right exactly in the wheelhouse of what this group is about. So thanks again.
Yeah, I mean, makes total sense for me. Thank you for having us. I'm the Kubernetes channel, so if something ping me in there, I'm happy to reply to questions. I mean, I will keep you updated if we have a new release or something new in there. I'm happy to point you and do another demo with the
Yeah, and feel free to drop updates in the channel for this group as well. We're open to anything that is under the open source umbrella coming in as news or promos. So thanks again. Thanks everybody for joining, and this group meets every 2 weeks. So we'll see you at the next one. Bye.
Bye-bye. Thank you.
Bye.